So this first problem, find the zeros of the polynomial. Show your test for 1 and -1. State the number of real roots. Okay, we're not going to do that one. That sentence. Miss Arnold wrote this review. It's really good, but I didn't make y'all do that. Find the zeros. So show your test for 1 and -1. What does that mean, the test for 1 and -1? What kind of math is that asking me to do? Was I recording myself just now when I said that? I think I was. Okay. What does that mean, show your test for 1 and -1? What kind of math is that asking me to do? That stuff right there, that synthetic division, right? So we just set up we do our synthetic division testing 1. And then the numbers I write are the coefficients from the polynomial. And you have to check if it's missing any x's. Do you see any x's that are missing? No. Okay, good. So set up your coefficients like this. And then we're going to do our synthetic division, but what is our goal? We're looking for what to happen on the synthetic division. Like, how will we know if 1 is a 0 or not? If there's a remainder of 0. So we bring down the first term is 2. We bring this down. We do the 1 that's in the little box. We do that times the 2 we brought down. So 1 times 2 is 2. We write that under the 5, and then we do what with the 5 and the 2? Add them. And then you repeat that process over and over. Right now I do the 1 in the box times the 7 and write that under the 11. And 11 plus 7 is 18. Now the 1 in the box times the 18, write that under the 20. Add gives you 38. 1 in the box times 38, add it to the 12. So what's up with that 50? It's not what? Not a 0. Exactly. So the 1 doesn't work. And also, by the way, here's just a little clever trick. I already knew just by looking at the problem, I could never have gotten 0 because notice every single coefficient is what kind of number? Positive. In order to get a 0, you have to have some negatives in there somewhere, right? In this particular case, nothing ever would have given me a negative. So if you were sort of critical thinking, you really didn't even have to do that math because you know it could have never ended up as 0. But we did it so we could review synthetic division. But anyway, so the 1 doesn't work. So now let's try -1. So I'm going to do my synthetic division quietly so that you can do yours uninterrupted. And then we'll compare. So you should have had a remainder of 0, yes? If not, check your math with mine quickly. So because we have a remainder of 0, that means that x equals -1 is a 0. It's a solution, it's a root. What factor corresponds to x equals -1 as a 0? What factor goes with x equals -1? Remember? X plus 1. Thank you. All right. So this is just a starting place, okay? So we have one factor, we have 1 0. How many zeros is this problem going to have? 4. Where'd you get that from? The biggest exponent, right? That's called the degree. We are going to. We are. That biggest number, that's the exponent on any of the terms, that's called the degree. In this case, it's 4. And that tells you how many zeros you're looking for in your final answer. You're going to have 4 zeros, 4 solutions, okay? But what we're going to do next, so right now we've just found a 1. So we need to find 3 more. What we will do is use these coefficients, that 2, 3, 8, and 12. Now that's 4 terms, and we can try grouping on 4 terms. And grouping does work in this instance. So that's our next step. So I'm going to add the x's back in, starting with 1 degree less. So the 2 coefficient will begin with 2x cubed. The 3 gets an x squared. The 8 gets x. And then the 12 is all by itself. All right. So I'm going to do grouping on this quietly while you do your own grouping. And then in a moment, we'll compare our notes, okay? Which part? From the highlighted numbers right there. It always starts with 1 degree less than the original problem. It's like around 12. So now we have factored by grouping. I've got 2x plus 3. I have x squared plus 4. Please remember, I also have this x plus 1 from my first round of synthetic division. So I'm going to throw that in there as well. And now, because the problem asked me to find the zeros, so that means I have to take each of those individual factors and solve them, right? What would make each of those equal to 0? And we already know that x plus 1 gives me -1 for a 0. 2x plus 3, now that's not an insider's lie because there's a 2 in front of the x, okay? That's the problem with shortcuts like insider's lies. If you forget that they only work in very special circumstances, then you try and apply them all the time. But to get a 0 for a factor, you literally just set it equal to 0. It's like a little baby equation, and then you solve it. So I subtract 3 from both sides. And then I divide by 2. So x equals -3/2. And then x squared plus 4, we're going to do the same thing. We're going to set it equal to 0. And then I subtract the 4 to both sides. I get x squared equals -4. And then I square root both sides. And what is the square root of -4? plus or minus 2i. Was that you, Arden? Well, the square root's gone, but yes, and then we have 2i, so plus or minus 2i. All right, so these are my final solutions. I have -3/2. That was from here. I have -1 from before, and then plus or minus 2i. How many solutions is that altogether? Kind of. The 2i looks like it's only one thing, but it's a plus and a minus. Yeah, so that's actually 2. So there's really the 4 altogether, which is what we were looking for. We talked about at the beginning of the problem. So remember that the square root of -4 is really the square root of two different things, -1 and +4. And so when I take the square root of -1, that comes out as I. And when I take the square root of 4, that simplifies completely as 2. Did that answer your question? Because I also heard you say something about insider's lie, so maybe I didn't answer your question, actually. Yes, yeah, just set it equal to 0. Because that's what it means to find a 0. You're literally finding what x values would make that factor equal 0. So when we set it equal to 0, that's why. Okay. All right, I'm going to give you a minute to do this part on your own, since it's not like algebra. Determine if each of the following is a polynomial. If it is, state the least possible degree and the end behavior. If it is not, state why not. And as a reminder, that least possible degree part, remember that was you find the turning points, the number of turning points, and do what to it? Anybody remember? Do you remember? No. You find the number of turning points and you do some math to it to figure out what the least possible degree is. Anyone? Anyone? Bueller? You add 1. So if you're watching the video at home, just pause it now and do A, B, and C. Remember once I start talking about, which I know is what you're waiting for anyway. All right. So the thing about the polynomial determining yes or no, if it's a polynomial, remember we've talked about how polynomials are continuous. They don't have any breaks in them. They also don't have any sharp turns. Like we talked about how absolute value has like a corner like piece to it. So it's not considered a polynomial. And we talked about how the domain is always -infinity to +infinity. So having reviewed that real quickly, what would you say about A? Is it a polynomial, yes or no? No, right? And so if you had to give a reason, because it's asking you to, you'd say no because why?
It's 2 lines. You know 2 lines? Polynomial cannot have 2 lines. Does it say that?
Sure. No, I wouldn't. Yes, kind of. Kind of. I like these words better. It's not continuous. Or like Zach said, there's a break. So it is not. What would you say for B? Is that a yes or a no? It is yes. It's smooth and continuous. There's no breaks. It also says state the least possible degree. So here's how we did that. We found the turning points, when it actually turned direction. And I 1, 2, 3. Technically, we didn't talk about this situation here where it kind of shimmies. So I actually would take a few different answers. At a minimum, I would take the 3 actual turning points where it actually changed direction. And then you add 1 to the turning points and you get 4. That thing I put the arrow on is like a special circumstance, which I don't want to tell you about because I don't want to confuse you, but we are going to be talking about it when we come back after Christmas break. But for now, we'll keep it super simple. Least possible degree, we're going to say 4 because there's 3 turning points plus 1, and that gives you the least possible degree. And the end behavior, that one you should remember. What's the end behavior for B? We talked about how it's the easiest thing you're going to do this year besides put your name on your paper. Up, up, right? So you need 2 answers, the left end behavior and the right end behavior. It's this stuff right here. It's X. Oh, is it? I'm so sorry. Yes, I am totally marking. I told you I was going to make mistakes because I haven't been at work for a while. So many things to remember. Thank you. And then for C, is that a yes or a no as for a polynomial? Is it smooth and continuous? Yes. The number of the least possible degree is the number of turning points plus 1. How many points do you see the graph turning direction? 2. Here and here. So then you're just going to add 1 to that. And the least possible degree is 3. And then it's just a general rule that we have. And then the end behavior, I kind of covered that. What's the left end behavior? What direction is it going on the left forever? Up. And on the right, what is it doing forever? Down. Okay, so up, down for its end behavior. Up, down. I'm pretty sure that's something we did when I was in athletics in high school. Okay. Yeah, right. Where you have to go up and then you have to go down and then up and like do quick feet or something. I'm pretty sure. I remember that. So this is the next page. Number 3, state the end behavior and y-intercept of the following graph, or sorry, do not graph. So this one, we're going to do the end behavior without even having a picture, okay? And so, do you remember when we did that little chart thing with the 4? You did it on your notes, you filled it in. Some of us filled in our notes. Here's the main takeaways from that chart. I'm going to put it down here somewhere. So this was our end behavior chart. And there's 2 things we have to talk about with end behavior, the A value and the degree. If A is positive and the degree, okay. Stuff is fast. And the degree is even. Okay, that's like x squared, right? A is positive, the degree is even. What's your end behavior? Up, up. But if you change your A to negative, what happens to that graph? It flips over, right? And so then if your degree is even, your A is negative, your end behavior becomes down, down. then if your A is positive, but your degree is odd, kind of like y equals x, that's an odd degree where the A is positive. Degree, yeah, degree is even or degree is odd. So, and these are just examples that help you to remember. These are just examples of things you already know. And so you could deduce everything from there if you wanted to. So y equals x, when A is positive, the left side goes down, the right side goes up. But if you were to make the A negative, it would flip the graph like this. And so then the left side would be up and the right side would be down. And then, so going to problem A, it's asking us for the end behavior and, oh, the y-intercept. Okay, that's going to be super easy for these problems. So end behavior is the A value. By the way, what is the A value in the first one? Do you remember what A value is? I'm glad you said that. It's not 12, but 12 is C, right? Or C. This one actually has way more terms than C. It's the constant. A is this right here. The coefficient of the first term. That's your A value. And the question is, we don't really care what the number is. The number could be anything. The number could be pi, okay? We care about, is it positive or negative? So what is A value here? Positive or negative? That one. It's positive, okay? So A is positive. And the second thing we need to know is the degree even or odd. Well, what is the degree here? 4, from that 4 right there. Yeah, it's even. So A is positive. So what does that mean for my end behavior? Up, up. What's the second thing the problem is asking me for, though? Okay, thank you. Now, when your polynomial is written in standard form and not factored form. Okay, so standard form, here's the difference between standard and factored form. These problems are standard form. The ones down here that we're about to do are factor form. So when it's in standard form, your y-intercept is just, it's a point. So I'm going to write an ordered pair. And then you're basically plugging in 0 for all the x's. Okay, that's what a y-intercept is. It's when the x value is 0, where does the graph cross the y-axis? But what happens with all those terms if I put 0 for x? Yeah, they all turn to 0. They just drop off. And so I'm only going to be left with which number? The negative 12, right? Because if you plug 0 in for all the x's, they all go away, leaving you just this number at the end. So your y-intercept is going to be 0, negative 12. In other words, it's 0, comma, whatever your constant is. Can you explain that again? Yeah, of course. So the y-intercept is where the graph crosses the y-axis. And everywhere on the y-axis, x equals 0. So I find the y-intercept by plugging in 0 for x. But each of these things has, if I put 0 for these x's and then multiplied it, like right here, 16 times 0 is just 0. Here, 2 times 0 squared is just 0. So the 0 makes all of these drop out, right? But it doesn't make the negative 12 drop out because it doesn't have an x on it. Just for these forms. When we do number 4, we have to do a little bit more math. But if it's in standard form, then yes, your y-intercept is whatever your constant value is, the number that doesn't have any x's on it. Okay. Y'all take a second and try B by yourself.
Do the next problem, guys.
Okay, so for M behavior, look, I'm remembering to unfreeze the screen. Okay. 2 things. Whether A is positive or negative, and whether the degree is even or odd. So for part B, before you even tell me if A is positive or negative, what is A? Which part of that expression is the A value? Which part of the leading term? The coefficient. And what is that here in this case? -2. So when we're trying to decide if A is positive or negative, it's very helpful if we're clear on what exactly the A is anyway. And it's the -2. Okay. The degree is the 3 on that term. So those are the 2 parts that we're looking for in the first term, the 2 things that we're considering. So now my question is A positive or negative? Negative, good job. And then is the degree even or odd? Odd, thank you. So with a -A and an odd degree, even without any picture at all, we can already tell what the end behavior is. What is it going to be? Yes, lift up, right down. Thank you. And then the y-intercept is super easy on this problem. Parentheses 0, comma 3. On standard form, the constant is your y-intercept because the x is equal to 0, and it would make every one of those terms that has an x in it, just make it go away. I was going to say go bye-bye, and then I knew I would hate myself, so I didn't say it. I do still say potty, though, because I've raised 5 children, and I think I will probably always say go potty. But go bye-bye is just off limits. All right. Does anyone need these before I slide it up? Yes? Okay. Last section. It's still asking me for a few things the same from the section before, like it's still asking me for end behavior and y-intercept, but it also is asking me for this additional thing called degree. So we have to do a little bit more math on these problems than we did in the previous one. So if you notice, all right, so here's the thing. These are in factored form. What we're missing that we had up here was already knowing what the first term is, like right here. If you already have the first term, it's very easy to see the A value, and it's very easy to see the degree. We can get that down here with a little bit of work. What we do is we take the first terms on the factors and multiply them together. We don't have to FOIL everything out and get the entire standard form. We just need the first term. So that's what the work we're going to do. It's like our pre-work before we answer the question. So we're going to figure that out first. In the first factor, though, notice it has a squared on the outside. So to figure out that first term actually occurs twice. And then we'll multiply it by the first term in the second factor and the first term in the third factor. Right, and that's going to give me x to the 4. And that's all we need now. We can tell the a value, which is 1. So our first term, x to the 4, that gives me my degree, which is 4. For end behavior, now we can just do the same thing we did in the previous two problems. You have to figure out if the a is positive or negative, and it is positive. The degree, which now we know is 4, is an even number. So positive a, even degree, means our end behavior is up, up. And then here's what's up with the y-intercept, okay? There's no constant term because it's in factored form. So what we're going to do is still do where x equals 0. We're going to plug that in for all the x's. And then we just do our order of operations. Okay, we simplify inside all the parentheses. Basically, we're just multiplying the last terms. So for the first term, we multiplied all the first terms. Now we're multiplying all the last terms. But we're being careful about the exponents, so we don't leave them out because it will change our answer. So there's me. I simplified the parentheses. Then I do exponents next. So I do the 2 squared. And then multiply straight across. That gives me negative 16. And my answer is not actually negative 16. My answer is an ordered pair. Do I write negative 16 first, or do I write 0 first? The first one is for the x value. Which goes here for x, 0 or negative 16? 0, thank you. So that is my y-intercept. You take a minute and try the b, and then we'll talk about it. If you're working at home, watching the video, pause your video now and try b by yourself. Okay. I quietly revealed my work so I wouldn't interrupt your thought process. But let's talk about it. The first term, did you get negative 5x to the fifth? If you didn't, does anyone have a question about how I got it? We all feel good about that? Okay. So here's what we get from the first term. The information is the a value and the degree. The a value is negative 5 and the degree is positive 5. So it asked me for the degree, so I boxed my answer for the degree. That's great. And then the end behavior, A is negative, the degree is odd, so my behavior is up, down. Got that? Okay. And then for the y-intercept, I put 0 for all the x's. Math ensued, and then I got negative 24. Did you follow your order of operations fine and get negative 24? There's several negatives in there. It could trip you up. And so then the final answer for the y-intercept is 0, negative 24. Y'all feel good about that? Any questions about that? Okay, no problem.